So today you're going to see the steps that we need to follow to deliver a 2D seismic refraction tomography survey. So the red sensor is called a geophone, and the geophone picks up the seismic waves. The seismic waves, the signal of the seismic waves gets digitized by these remote unit, or also called digitizer. Once the signal is digitized, it is sent through this cable to the data collector, so it can be visualized by the entire software. Geophones are connected to the remote units, and the remote units are actual digitizers of the seismic signal. The seismic signal goes through the cable and it reaches the data collector, where it is later seen by the software. The orange spot is where the plate has to be placed, so the impact is done at every single mark. The spacing of the plate, or the impact, is very important. The more impacts you have and the closely spaced they are, the higher the resolution can be in the case for seismic refraction tomography. So the spacing can vary from 1 meter to 3 meters, 5 meters, 6 meters, or 10 meters, depending on the desired resolution. So this is the first location of the seismic of the impact, and we're gonna place this metallic plate on top of that mark, and this is gonna be the first impact for this seismic refraction tomography survey. And we're gonna do a number of impacts, and we're gonna work our way towards the seismograph. So it's gonna be about 5 impacts that we're gonna do. And to do that, we need this hammer, sledgehammer, and the sledgehammer is actually connected to the cable line. Okay, the cable line snaps onto this seismic trigger. The seismic trigger just simply snaps to the cable line, and at that point I wait a few seconds before I can actually hit the plate, and once it's ready I can do that, and I can do a number of stacking. It can be 3, 5, 10 or so. So these 5 impacts actually become the seismic source. These seismic waves or seismic energy is picked up by all the sensors, and eventually we can see the seismic record in the computer. So we're done hammering the 5 different locations, and what's next is to produce a 2D image of the seismic velocity structure for these seismic profile. So what we do next is pretty much we look at the data and we process the data and give you a seismic velocity structure image of the subsurface, where you can actually see the depth to bedrock or the thickness of the sediments, the geometry and underground topography of the subsurface conditions. In some cases, you might be able to see faulting if present. You might be able to see weather zones. You might be able to see the fracture zones within the subsurface. So for seismic velocity studies, seismic refraction tomography works great for vertical with vertical geophones or with horizontal geophones if you want to get shear wave velocity structure. Other things we can do with this equipment are MASW studies and REMI studies and even reflection studies.